All right, what's up, everybody? Boom, boom. This one not working yet. Should be working. Yeah, go live. There we go. All right. Got our chat running. Okay, it's Monday. New week. I had another lecture today. Today's lecture in physics. What did I do? Oh, I did mechanical waves. Super cool stuff. So, we did transverse waves mainly. I mean, we also did technically longitudinal waves, but it was really mainly going over transverse waves. I was in Denver this weekend. I was playing a show. It was pretty fun. I think I got videos somewhere. Let's see. It was for, so Friday I played a show, and then Saturday I had a wedding that I had to go to in Denver, so it was kind of like a twofer event. What's up, SR93? Let me know if we're like dropping too many frames. Yeah. I see that. What's up, Shantrix? I'm good, SR93. I'm good, man. Zandri de Trois. De Trois? Du Trois? Sounds French to me. Yeah? Du Trois? Am I able to go over the second problem of the discussion worksheet, or is that just for the DA? What's up, Recky? If he's posted it, I'll go over it. No, you can ask whatever during office hours. Yeah, if you want me to go over stuff that happened earlier in the class, totally cool. Ooh, South African. Afrikaans. That's the language there, right? Afrikaans. It's spelled with like a double A, I think. Which is almost, it's kind of like Dutch, I think. Can you show us the most summer? Yes. So thank you everyone for signing up so far for summer camp. I'll make an announcement today. But summer camp officially doesn't start till the 7th. But I am allowing people to kind of test out how you would get points so far just from the dailies. And we'll give out like a gift card or something for, you know, we'll raffle off like the top people before summer camp starts. So yes, if you're registered, great. You can, right now is like a trial test period, so the points are going to reset on the 7th anyways, but I'll make an announcement about that later today, but you keep doing it now. Yeah. Sib says we only had to submit the first question, but the second is a Bernoulli's equation problem. Okay, cool. Yeah, I'm down to go through it. Let me see if I can access it. Where does he post the worksheets, by the way? I don't see him I don't see them in the modules. Yes, Equity. The points reset right once summer camp starts. Yeah. Otherwise, people who registered first would have an unfair advantage. You know this equity. Have you not been to one of our summer camps before? Yeah. I'll make an announcement about it. But yeah, we let people like try out getting the points during the registration period, but then I reset it once it officially starts. Under files. Oh, see, he's not posting them in modules. Oh, I see. Interesting. It's okay. Every TA is different. This is not what I want. That's the Kudu stuff. Let's get Kudu out. There we go. I see. He puts it in files. See, I would put this in here. I'm going to just do this for him because it's easier when it's modules. So I'm going to create a new module. I'm going to call this like discussion worksheets. Just easier. And then from here, I think I can choose the files. Wait, what? Let me see. Files. Here they are. So problems. Yeah. Let's just add that. Let me add some more. This is how I would do it, or how I organized things last time. So, there we go. Discussion problems 7-2. Ooh, so this hasn't happened yet. Okay, so we don't want to post that yet. Or does he already have those available? Can you see those? Can y'all see 7-2? Or I guess he did post them. And they are visible to everyone. Okay. Last time you did gift card giveaway at the start. Yes, correct. That is correct, equity. Okay, all right, cool. Then I'll add it to the. Let me add it to the module real quick for you guys. And then this one we want to publish the module. And then let me add some files. What's up, Sensation? Good to see you.
Yo, Afrikaans praat.
Afrikaans praat. Yeah, let me add that in. Okay, cool. So Sib says discussion problems. Okay, so was it these that came up?
Seriously, what's going on?
Oh, just some people asking some physics questions. There he is. There's Sensation. There is Sir Sensation. 6-30. Sup, Cletus? Who's saying Cletus? Who's Cletus?
I don't know what's going on.
I don't know what's going on, Cletus. Alright, one sec. Let me go find this file that they wanted. That was my internet speed
This is my
test.
wife and my sister.
Wow, dude, you impersonating a southern accent is fucking hilarious, dude.
Sorry, is it bad?
No, it's quite good actually. It's quite good, quite proper.
Okay.
See, it's if I were to do like a British accent, that's kind of I think like you doing a Southern American accent. It's pretty funny.
It's probably like me trying to do a Southern English accent. To be honest with you, it sounds off.
Like
Because they have a
Scouse?
particular cadence.
Like Scouse.
I could do Scouts.
Scouse, he says.
Hey, fuck! What the
Hey,
fuck are you doing over here in Liverpool?
Fucking Geordie.
Geordies. I can, yeah.
Okay. Cool. I think everything else is doing okay. Yeah, we got internet. We got uploads. I'm gonna hold off sharing my screen on Discord, just because I see like my bandwidth is like kind of strained today. But if someone really needs it, I'll show it. All right, let's start things off. Welcome everyone, Office Hours. My name is Dr. Gold with Sex Education. Streaming subject math, homework, science homework.
Nice.
Perfect.
All sorts of fun stuff. Sib's got a good one. This is a physics question. Again, if you are joining us from any of the other places, Twitch, YouTube, please feel free to submit a screenshot under help screenshots. Would love to go over them. We do have some good ones. I already see. Let me see. Is this? Yeah, there we go. Yeah, so we got some good ones here. Winnie's got one. That's a cool question we'll do. This looks very interesting. And then Matcha Bear. This looks like some sort of OChem. Good. Yeah, we got a lot of stuff to do today. Wow, sensation. We got so many things to do today. All right, let me see. Good times. Okay. A heavy plate of mass M is placed onto a column of liquid density rho and cross-sectional area A, like the one pictured. Gravity pulls it down, and the added pressure results in water shooting out of a small hole in the connected right column. The diameter of the small hole is very small compared to the diameter of the columns. Okay, cool. So I guess that tells me that the velocity of the liquid here will be very small compared to the velocity of the liquid here, right? Because we assume that the surface area of this hole is like really tiny compared to this, or more so that I guess the rate at which this decreases in level is very slow compared to the velocity of the water out here. Okay, set up Bernoulli's equation to solve for the velocity v2 of the water leaving the small hole. Hint, find the weight of the plate to find the added pressure, then add that to the atmospheric pressure to get the total pressure right beneath the piston. Okay. Cool, yeah, so let's set up Bernoulli's. Let's do it. Let's do it. We're going to call this... I'm going to call this, like, situation... Let's call this, like, A. And then, or let me use different colors for things, sorry. Let's call this A, and then let's call this B. Okay. So, Bernoulli's equation says, I think it's P naught, right? So, like, P naught plus rho GH plus 1/2 rho A V squared has to equal the same thing for the other side, I believe. This is me just spitballing off the top of my head. I'm pretty sure that's what it is. Yeah. Oh, it's just rho V squared, not rho A V squared. Okay. That makes sense. There's no area term. What's this cool stuff going on here, though? Let me copy this in. Okay, so there's no A here. Oop. Get rid of this. Go away. Go away. Clear. Yes, pressure energy, kinetic energy per unit volume, potential energy due to the height. Cool. Right. Okay, cool. All right, so then let's look at the two situations. So rho 0 for the first part here. So yeah, you are going to have P atmosphere, or sorry, P0. So P0 is going to have, sorry, here, let me make this a capital P. So it's different than rho. Okay. So here, this is going to equal to P atmospheric plus the pressure of the heavy plate. So pressure of the plate, let's just put that down there. And then rho GH. Which, okay, if I think we're gonna call this height equals 0, right? Let's call this h equals 0. So this is gonna be 0. And then 1/2 rho v squared. I think we're also gonna call this 0 because we're gonna assume that the velocity at which this drops is much slower than the velocity of the water coming out the top. And the reason why we're able to say that is because the diameter of the small hole is very small compared to the diameter of the columns. Yeah. So this is where, like, if A1 is much smaller than A2, you're allowed to say this. You see the UFO news in New York? What? I did not see the UFO news. Okay. Here you just have P atmospheric, right? This is, you know, just open to the atmosphere. There's no plate anymore. And now this is going to be plus rho G, and this is going to be, right, some height H. So we can just leave that as H. And then this is going to be some 1/2 rho V squared. Nice thing here is pressure of the atmosphere is going to cancel. Goodbye. On both sides. Then we have the pressure of the plate, which pressure is equal to force over area. So this is going to equal to the force of gravity on the plate divided by the area, which we can say is like A1. Let's just say it's A1. And that has to be equal to rho GH plus 1/2 rho V squared. Now the force on the plate is going to be big M times G. What's up, Jarvis? Okay. So you have big M. Force Snabbit says, I don't understand anything you wrote there. I think I have an IQ of 50. No. Don't worry, dog, don't worry. This is college level physics. Yeah. And I say to people, don't get too worried if you don't understand like what's going on here. It's okay. The main thing is for you to kind of like get exposure to what this is, so that when you see it later in life, it's like not super foreign or like new. Yeah, but don't worry about understanding everything. That being said, if you are in my physics class,
I was just about to say I'm an.
Yeah, what about you, Sensation? Do you get some of this? No,
I'm very in the vaguest possible sense. I mean, if he feels like his IQ's 50, mine feels like it's my shoe size. Yeah,
Is agreeing that I have low IQ really the sign that I have at least normal IQ? I think just by the fact that you're here for Snabbit, means you have a higher IQ than most people. Most people are just probably like mouth breathing and like watching like brain rot vids right now. Anyways. Okay. So then I think all we gotta do is solve. Do they give us a diameter at least or something? No, they just say area A. Okay, cool. Alright, so then yeah, this is just the equation is just solving this, which is kinda ugly, honestly. So it's just mg over A1 minus rho GH, and then all of this is times 2 over rho, and then this is equal to V squared. H2 is not 0. Well, yeah, that's why I put the H there, right? This is H, right? Yeah, so H2 is not 0, correct. Yeah. So H is just like where you measure it. They call this the common datum, right? Or something, datum. So if I'm measuring the height here to be 0, then at situation 2, situation B, I guess, the height is H. Yeah. Okay. So now you're here. Let's see if some things are nice. I guess the 2 is going to be like whatever. So what? 2mg, or big mg, sorry. Or we could pull a g out, right? Let's pull a g out. So 2g, and then I'm going to say m over rho a1. Yeah. Minus h is equal to v squared. Okay, cool. So then the square root of that's equal to v. I feel like that's correct. I don't know. Did he post answers for this, guys? Did he post answers yet? Probably not, right? Force Snap says, I don't agree you should remove the M. I can take the G out. I can definitely take the G out, Force Snap. You know what's the cool thing here is I can take. Let me take. Let's go check. Let's go check some ChatGPT. See what ChatGPT says. I like to always, just kind of reaffirm that I'm correct. Replace it with L. But they said height H, I think.
The diagram's kind of weird, though.
Yeah, I agree. I mean, he probably
like,
drew it
this
himself.
This is H, but not the whole thing.
Right. Yeah, well, that's the thing, is that the pressure at that same height is the same. Here, let me just solve this.
Oh, yeah.
I'm just telling ChatGPT to solve this, and we'll see what it gets. But Yeah, you're right that we're calling this bit h because all we care about is the difference in the height from where it is like spewing out and from where it's getting like pressed down on, because I know that the pressure here and the pressure here must be I think the same. Yeah.
Just from the picture, it looks like where H is drawn, the atmosphere would be 1.
Oh, I see.
Because there's nothing there.
Right. Well, this is open. Apparently, this is open, which means you have atmospheric pressure coming in and pushing down, but then you also have the weight due to gravity pulling it down as well. So you have two different things. Yeah. We don't care about any of the in between stuff below it, because the pressure is all the same there at the same heights. Yeah. All right, but let's see what ChatGPT said for an answer. Blah 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 blah. Okay, cool. I think we got the same answer here. Let's see. They got this. That's what we got. No, that's the same one. Let's see. V2 is 2. I pulled a G out. They left it in. Row A. They say plus H. I have a minus H. I'm going to ask him if they're right. Force says, I'm happy people like you exist and that the world has technology it would have today. Imagine all people would be like me, just working, eating, sleeping. Okay, thanks. I'm glad I exist too. Okay, I want to ask ChatGPT why I got plus H though. I don't think the plus H is right here. Oh, see, yeah, they have Z1 minus Z2. It should be Z2 minus Z1. Well, yeah, see how they say Z1 minus Z2 is equal to H? This is wrong. I would say that. But H is equal to Z2 minus Z1. Just tell him. Tell him he's like, yo, dog. Yeah, see?
That'll be like, yes, you're right.
I always love when it says, yes, you're absolutely right. I'm like, thanks, dog. Yeah.
The only problem is it agrees with you consistently if you tell it something that's wrong. So
this is where, like, dude, people are using this to, like, gaslight themselves in being correct in, like, relationship issues and whatnot. They'll be like, oh, my boyfriend said this and this and this. Am I crazy or is he the one that's crazy? It's like, no, of course, you're fine. The user is always right. That's what Zach says. Yeah. Okay, so I think we're good. Cool. It says after leaving the top, the water gets shot straight upwards. What is the maximum height above the top of the right column that the water will reach? You can definitely correct ChatGPT. Dude, ChatGPT makes mistakes all the time. Yeah. Anyways, so yeah. And then, okay, so the maximum height that something's going to reach, that's also just, you can do conservation of energy. So that's part B here. Yeah, sensation. Zach says, cheers to the Dr. Eggman Robotnik t-shirt. Yeah, you've had this shirt before. I've seen this one. That's the good one. It's the Sonic.
I rarely buy new clothes.
I just make my clothes, honestly. I don't really buy shirts. I just make shirts because I have a silkscreen printer thing. Like I designed and like made this shirt. Just come up with like cool.
Oh no,
designs.
dude! I need to make sure that most of my shirts are like made rather than printed because prints don't last.
That's
me
true.
Anyway.
Yeah.
They tend to get wrecked really quickly.
So the trick for me is like you gotta wash it on like the delicate cycle on cold water, and then you have to like air dry them. That's the way the print stuff lasts the longest.
But it doesn't work in this country. It's
oh, because it's too humid.
Yeah, it's always damp. It never rains, but it's always damp.
Yeah, and if you have too much humidity, if there's too much liquid in the air, then like air drying doesn't work.
Kind of funny how everyone's like, "Oh, it rains all the time in England." No, it really doesn't. We have our water table is actually, non-existent most of the time.
You know, and I'll explain this later, but I was at an Airbnb in Denver this weekend, and they didn't have AC, which would be kind of a problem because it was 95 degrees during the day, right? But they did have a swamp cooler. Have you heard of a swamp cooler sensation? No. It's cool. It's kind of like a passive way to create air conditioning without using like too much electricity for like a compressor or something. Yeah, here I'll show you real quick. It's cool because it actually uses a physics concept in order for it to work. I want like a diagram. Yeah, here we go. Okay, this is kind of cool. Or yeah, I guess this kind of works. Or I want like a nice. Here we go. This is it. Let's do this one. Okay. So how a swamp cooler works is you have like this water reservoir, okay? Just like regular tap water. You do want it to be like decently like cold, like not super hot. And then what happens is you have a fan that pulls whatever the hot air is in your room. And as that hot air gets pulled across like these pads, the water evaporates. And then a cool thing we learned from chemistry with evaporating is that evaporating is a endothermic reaction, which is kind of weird, right? So endothermic means it absorbs heat. It needs heat. And so yeah, what happens is if you have, let's say, for instance, liquid water, then air, if it's hot, will give off energy to this liquid water to then cause the molecules to have enough kinetic energy to then start turning into vapor. And so what that does is you're removing heat in the air in order to evaporate water inside of a swamp cooler. And the only electricity you need is to run a fan, which is not very electrically intensive at all. A lot less energy demanding than, say, for instance, running a compressor, which is how like modern AC uses like gas compression. It uses a compressor and an exchanger or something to work. So the only downside to this, and this is why it's sensation, it probably wouldn't work where you are, is that you need the ambient air to be dry. Because if the ambient air is wet, then it doesn't want more wetness to get into the air. So then it's very hard to evaporate water in air that's already full of water, like humid. So a swamp cooler would not work where you live. But it did work in Denver because Denver is very high altitude, so it's very dry. And the other condition about this is that you need to do it somewhere where you have the ability to circulate the air, because otherwise you end up just like humidifying. Like if you're in a closed room and you're running a swamp cooler, all you're doing is basically humidifying the air. You're just taking water and like turning it into like swamp water. So you need to have ventilation. Yeah, it's pretty cool. I don't know. My man. It was physics. I was like, wow, we don't have air conditioning, but we have this swamp cooler, and this swamp cooler works because of physics and like chemistry. They use these in the desert.
Some PhD.
What PhD?
Some PhD told me. When your car's hot, you open the back window of the car opposite the driver's side, and then you open the window on the driver's side, and then you open and close the door 3 or 4 times. And all of a sudden, it's really cool.
Yeah, because what you're doing there is you're creating a column for air to like escape. Yeah.
There was a word that used a
like a vacuum, like a pressure like negative pressure. It's called like negative pressure, I think, usually. So when you're taking the door and like in and out, this is kind of like you're creating like a drop in pressure within the car, especially when you pull the door out. It's the same way as like with your lungs, right? We explained this on another stream. How you breathe air is you expand your lungs out, and that increasing volume creates a drop in pressure inside your cavities, your lung cavities, and that causes outside air to get sucked in. So with the car, if you're opening the door really quickly, what that does is that creates negative pressure to pull, I would say, air from the driver's side into the vehicle to pull cold air in, and then you want it to exit the back of the car such that it circulates and cycles it. Yeah. That's pretty cool. Yeah, I don't think you need to actually... I think you only... The game... Did I already lose it? God damn it.
The game 2.0. You are now breathing manually.
That is, yeah, it is a funny one. Okay. So for the last part, or the part B here, Sib, what is the maximum height at which the... Oh, one sec. We gotta refresh this. I've been streaming for too long today. Here we go. Okay.
Always run everything locally.
Okay. In order to figure out the maximum height that the water reaches, so this water up here, if we want to figure out the maximum height, let's call that like big H. Right, so it's going to come up here, right? This is like some big H. Okay, you can use conservation of energy here. So energy before, we'll assume that this is like 0 now. So this goes away. This is just this. And then here at maximum height, this velocity should be 0. So, and then the m's cancel. Don't care about the mass. So you just get h is equal to v squared over 2g. This is a thing that comes up in kinematics a lot. We should remember this. It's just easy. And so in that case, and that's so that's big H is what we're gonna call that. That's equal to 2g m over rho a1 minus h all over. Oh, look at this. This is cool. Over 2g. This cancels out. And nice. You just get h is equal to m over rho a1 minus h. Cool. That's actually not too bad. We could go back and ask ChatGPT. Let's have it see what part B is.
Oh, quick segue.
What's up?
There's a new company called Sunbird. Is it Sunbird?
Sunbird.
Have you heard about this?
No. What does Sunbird do?
It's a UK company who reckons they can cut the travel time to Mars to 30 days.
Wow. How?
What is it? A direct fusion drive.
Oh, or like an ion thruster, maybe?
Incredibly high exhaust velocity.
Like an ion thruster?
No, it's not an ion drive. I said that. It seems to be a plasma drive.
Oh, okay. Well, plasma just refers to like any sort of like space is basically plasma. It's gas at which the ions have been like stripped off. It's deionized gas. What's it called? It's called Sunbird? Let me just look it up. I'm curious. Nuclear fusion rocket. Okay, cool. I like this design. Cool looking design. Looks fucking rad, dude. Sunbird space nuke? Dude, what? And I love how this is being posted by The Sun, which is like y'all's version of the National Enquirer. Britain's secret space nuke that could help us colonize Mars or even take trips to the edge of the galaxy. Okay. Curious. Okay. The only problem is like you have to do fusion, which is very difficult. Like we're still trying to figure out how to do fusion. My whole like PhD thesis was all around like fusion. And probably one of the main reasons I got out of academia and doing fusion is because it's so far away. Fusion is I think we will be lucky if fusion happens within my lifetime at this point. There's a joke that fusion's always 60 years away. Like, it doesn't matter when it is. It's always 60 years away.
Yeah, I heard that too. It was in the 1970s. There was a book that was talking about it in the 1970s.
Yeah.
But no, we have reached a critical point now. The last experiments did exceed the energy output of the energy input. So we've at least got that far.
Yeah, so we've gotten past break even, but there are some caveats to this. We've gotten past break even from the input power, not from the wall. So there's a difference in the power that is absorbed by the fusion device, and there's the power that was provided from the wall outlet to the fusion device. So yes, we're break even like from the science side, which like cool, yeah, that's awesome. But from like a commercial, economically viable point of view, it's still negative because there's still efficiency problems with getting wall energy to like usable fusion machine energy. I say fusion these days is an engineering problem. It's no longer really a physics problem. Physics has already come up with so many different like hacks and like unique ways to try and make fusion more efficient. But at the end of the day, it's the engineering that's really holding us back. Like, we don't have the materials to do stuff. They haven't been like engineered yet. Yeah. But it's cool. I mean,
what if they actually captured an asteroid?
What's up? What at the asteroid?
It's worth quadrillions
with all the tritium and stuff on it. Yeah. I mean, it'd be useful. I mean, that is fuel that's needed for fusion, for sure. Like deuterium and tritium, which is called heavy hydrogen. The moon also has a lot of this apparently, which is like, let's go mine the moon.
H3.
Yeah, it is H3, I think. What is it? Moon has, I think it's tritium. Helium-3, sorry.
I don't mean to go off on a random tangent, but have you ever seen Iron Sky?
No.
Go watch it. It's so stupid.
Iron Sky. Oh, this looks great. The Nazis retreated to the moon. What?
Yeah, but the whole thing's just stupid. It's a comedy. The entire thing is just a.
Oh man, I always love these like alternative reality Nazi films, where like the Nazis like went to Antarctica or something. I don't know, which I think apparently is true. But there's all this. Like, have you seen the conspiracy theories?
About the moon?
No, about the Nazis having like a secret base in Antarctica.
Oh no, I've not heard that one.
Yeah, and they were like making deals with the aliens. I don't know. I've seen it at some point.
Of course they were.
Of course they were. Yeah. Anyways, okay, let's see. M row A1 over H, and yes, Sib, that's the same as here. So I think we're good there. The last part of this question was, at what value of H will the water stop shooting out? Find when V2 is 0. Oh, well, that's cool. I mean, we just need this to be equal to 0 then. Okay. So in that case, the height would be M over row A1, right? So I would just say when H equals M over row A1. V2 will equal 0. Nice. Okay, I think that's it for that one. So, cool question.
Okay, I do have a genuine question, actually.
Yeah, what's your genuine question?
A physics one.
Yeah.
Well, because we were sort of getting there before, but too many questions and too many people. Yeah, anyway.
That's okay. What's up?
Right, so within the American system of mains electricity.
Yes.
How would you... This is probably more of an engineering problem then. How would you then increase the voltage within the house to 220 or 230 volts?
Good. You use a transformer.
So you can run a kettle.
It's a transformer is what it is. So, and this is something I will teach in my physics class later. Let me see if I can pull. Let me get an image of it. It's called a voltage transformer, and it uses, I want to say it's Lenz's law. But basically, if you have different number of coils, let me see, like small. Like, have you seen these before? You've seen these in electronic devices, right? Or sorry, you're watching on the Twitch.
Similar.
Yeah.
There's a bit of a lag here.
Yeah. Okay. These work by taking You have something like, here, it's
I was going to say they just look like big electromagnets.
They do. Yeah, so this is the, let me get the image here. Different number of coil windings, correct, one factum, yeah. So this is how they work. So you have a primary coil, so this is like your voltage source, so primary, and that runs at a certain amount of voltage, and you have that go around a certain amount of times, and then you have a secondary circuit on the other side of this iron core, or whatever dielectric. And depending on the number of turns in each side, that'll either take your voltage up or it'll take your voltage down. So something like this on a larger scale is what's used to like transform the voltage in your house to different voltages. It's either like a step up or a step down transformer. And the reason why
this... I don't know, but how long do they last?
How long do they last? Oh, forever, dude. Yeah. I mean, yeah, transformers. Okay. I mean, yeah. I mean, it's just a coil. As long as you're not running too much current to like melt the coils or like degrade the iron, because current does generate heat, right, through like resistance. They pretty much last forever. I'm pretty sure transformers. But yeah, I think it has to do with Lenz's law, which is like the magnetic flux through any surface has to be constant, and so if you have more loops, then for the same amount of flux, you're going to have less current. And then less current means less voltage. But if you have less loops, then you have more current per loop. And then more current V equals IR. That creates more voltage. So I will go over this. I'm pretty sure I go over this in my... No, actually, I don't. Because that's magnetism. And that gets covered in 1C. Aw. Okay. But yeah, someone from chat says they last a long time. They vibrate quite a bit. That's why you hear transform. That's why you can hear them. Yeah. Yeah, I guess they do vibrate. There's probably like some sort of some force that's like causing them to jiggle. Because this is also a physics thing. You have F equals ILB. That's called... Fuck, who is that? Somebody's law. Lorentz? Is it the Lorentz force? Is that what it is? The Lorentz force? Lorentz force. Abu says, where can I find the recording for today's lecture? It is on YouTube. Let me go find the link for you. I put it on the Campus Wire. So if you go to Campus Wire, here's all of the... I wonder if I can paste all these, but here's the most recent lecture if you want. Where's the chat? There you go. That's the most recent lecture we had. And then here, I'll post the other two if you want them as well. We'll get 4 and 3 as well. Not that one.
I was going to say, is this on YouTube now? You can just look up the thing.
Well, they're unlisted technically because I didn't want to like keep them public indefinitely in case like someone got mad at me for like privacy issues. So I have them unlisted, but then I post a link for like individuals to see it. So you can't like Google like search them up. I may at the end of the course just make it all public in like a playlist or something. I don't know. I'm kind of playing around with like who's gonna get mad at me for like privacy issues. Anyways, yeah, those are the lectures, Abu, if you want to see them. Okay. Nice. I think that was a good first question. Thanks, Sib. Appreciate it. And we got some web help screenshots. Anurag has sent one. Ooh, the wave equation. That's cool. Let me see which one he wants from this. Anurag, someone submitted this on the web. Can you tell me which one you want help with? What's up, Famished? Like 16.15, 16.16. Looks like we're doing vector potentials and stuff. No. Yeah. Oh wow, this is in spherical coordinates. Yeah. Yes. Someone, let me know which one. 5K. Are you here? And then 16.6, you mean 1/6? Luckily, they gave me 2 attempts. Do 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 do. Okay. Okay, let's see. It says, what's up, famished? It says, wait. Okay. Oh, I see. Yeah, the chat came in. Yeah, I got you, famished. I got you, dude. You're fine. All right. I assume Ritu, is this the one you need help with? Ritu Bajaj, is this one? So f of r, so they say that f is a function that is spherically symmetric. So that means all it depends on is the radius, right? So, and then I think they want us, yeah, so from the definition of this. So this is nabla, which is like a derivative in all directions. So nabla is equal to, it's an operator. It's like d dx, and then we can do this as like kind of as a vector. It's like d dx, comma, d dy, comma, d dz. So then nabla squared is the second derivative, I believe. Okay. So if we assume that f is only a function of r, right? This implies that, and then, oh, I see what we got to do. We got to think about r in Cartesian coordinates, which is the square root of x squared plus y squared plus z squared. Okay. So let's do if we do, let's just do nabla f. Think you do need a good knowledge on, well, basic algebra, I think. And then as we're showing here, it definitely helps to understand calculus, even like vector calculus, because, okay, this is going to end up being df dx, comma, df dy, comma, df dz. And this is going to be a vector, okay? So we're going to take the derivative in each direction. So let's look at the x component first. So let's, for instance, look at df dx, right? So that's going to be d dx of f as a function of r. Yeah, well, yeah, okay, good. So, and if it's just a function of r, that's going to be df dx times dr. No, it's going to be df dr times dr dx. This is the chain rule, right? Do we remember this from calculus? Right? Do you see how this looks like the same as df dx? So you take the derivative with respect to r, and then you take the derivative of r with respect to x. And so that means that d squared f dx will end up equaling d dx of df dx, which is now equal to d dx of df dr, which I'm going to just call that f prime of r dr dx. Okay, but we can figure out what dr dx is because we have this definition for r, right? So dr dx is ddx of this x squared plus y squared plus z squared to the 1/2. This is, again, another chain rule. So this is going to be 1/2 x squared plus y squared plus z squared to the negative 1/2 times the derivative of what's inside, so type times 2x. So the 2's cancel. And you end up getting 2 over x, sorry, you get x over x squared plus y squared plus z squared all to the 1/2. And that's equal to x over r. Okay. So then doing this, you get ddx of f prime of r x over r. Now this is a product rule. So derivative of the first times the second. So that's going to be f double prime of r dr dx times x over r times the derivative of the second. So plus the derivative of the second. So that's just going to be 1 over r, right? So now you have f prime r 1 over r. Well, wait a minute. But r also depends on x. Oh, God. Bro, this sucks. This is such a fucking bitch.
Oh, no. Oh, no. No, no. No,
Oh my God. Because, yeah, all right. Because this right here is now a quotient rule. So this right here, right? This was a chain rule. And then this right here is a product rule. Okay. So by the quotient rule, oh man. Derivative of the top with respect to x, so that's 1 times the bottom, which is r, minus the derivative of the bottom, which is x over r, times the top, which is just x, all over r squared. So that gets you 1 over r minus x squared over r to the third. Okay, so then this all goes here. And so what you're left with is f double prime of r. dr dx is x over r. So that's x squared over r squared plus f prime of r. And then you have 1 minus r, 1 over r, minus x squared over r cubed. Cool. Great. That's d squared f dx squared. Nice. Okay. Turns out, we do the same fucking shit for the y direction and then the z direction. I'm not going to re-go through and do all the same stuff. It's the same. So, by like comparison, right? Because r is just x squared, y squared, z squared all added to each other. You're going to get the same thing for the y derivative and the z derivative. The only difference is you replace x with y. So then this is f double prime of r, y squared over r squared, plus f prime of r, 1 over r, minus y squared over r to the third, and then d squared f dz squared is equal to f double prime of r, z squared over r squared, plus f prime of r, 1 over r minus z squared over r to the third. Okay. All right. And then if I add all these up together, right, okay. And actually this is interesting. I think this squared f is equal to this dot this. Is this what it is? Is this what like the second derivative is? What do they call that? Second nabla. It's called the Laplacian. Yeah, where is it? Yeah, it is usually denoted by the symbols of that dot that or that squared, the nabla operator. Yeah, the Laplacian. Here we go. Very cool. So, where's like Laplacian? Why are they doing? I want the upside down triangles. There we go. Okay. Yes. So nabla squared is not doing it twice. It's doing it one time and then dot producting the derivative with it. So you get a scalar. Dot products get you scalars. So this was the first thing, and then we took another derivative. So, and then now we're going to add all those up. So this is also equal to, they say, the sum over like x, y, and z of d squared f d. We would say like di. Let's say like I is equal to that. Di squared. So when you add all of these up together, this is actually really cool what you get. You end up getting f double prime, and then it's x squared over r squared plus y squared over r squared plus z squared over r squared. Yeah, for sure, Seb. Damn gold, $589. Yeah, we got some donations. Okay, so that's that, and then we get plus f prime, and then that's going to be 3 over r, I believe, right? Because we got 3 1 over r's, and then that's minus x squared plus y squared plus z squared all over r to the third. Oh, very cool. Well, x squared plus y squared plus z squared is r squared. So this just becomes r squared over r squared, which is just 1. So we just get f double prime of r times 1 plus f prime of r, 3 over r, and then this is going to be minus, this is r squared. So this is r squared over r to the third. So that's 1 over r. Oh, very cool. So this is f double prime of r plus f prime of r. This is 3 over r minus 1 over r. So that's 2 over r. Okay. Cool. And then where's the sneaky bit? What's the last bit here? I'm trying to show it's equal to this. Let's see if we can do this by inspection. I'm curious. One over r d squared r f. Okay, so this would be 1 over r, and then by a product rule, right? That would be, and then let's say like ddr, and then we would say dr of rf. If we do that, that's 1 over r ddr, and then this is going to be 1 times f plus f prime of r times r. Okay, and then do another derivative. 1 over r f prime plus, okay, that's going to be f double prime of r times r plus f prime of r. And let's see what we get. Oh, very cool. I get 2 f primes. So that's 2 f prime of r over r plus f double prime of r times r all over r. This cancels out.
Nice.
Oh, wow. And then this right here is the same thing as this. Oh, my God. We finally did it. Yes. Nice.
Well done! Well done!
Jesus. Okay. That's how you do it. Read 2.
Hola, soy mindfuck.
Soy mindfuck. Indeed, dude, bro. Like, look how much shit we had to do to derive this. I'm not even university student. I still understand this. Nice. So you did understand this? It's not that bad, honestly. It's just, there is a lot of calculus involved. Again, you have to know product rule. You have to know quotient rule. You have to know chain rule. Like, you have to be very good at your derivatives. And then, you have to be kind of okay with understanding how things in, like, multiple dimensions, like how vector calculus, multivariable calculus works. It's just like some slight extensions. Okay. But good question. I liked deriving that. It's a lot easier if you just use if you convert to spherical coordinates and then just take derivatives. But it is possible to do with what is it? It is possible to do it with Cartesian. It's just a bitch. It's a huge bitch.
Now do it in quaternions.
Quaternions.
Oh no.
That's what I say to that sensation. Oh no.
Everyone's like, you should just use 3 times 3
Yeah.
matrices. And it's like, no. Quaternions are there for a reason.
Quaternions. Okay. Okay, let's see. We got a couple of the questions. Winnie had one. Where's it? What's up with Winnie? Is Winnie around? Winnie had a question. I don't see Winnie in the chat. Okay, I'm just gonna pull some up.
Winnie the Pooh.
Christopher Robbins.
Oh, bother.
Oh, bother. Isn't there like some debate on the gender of Winnie the Pooh?
I'm not getting into that one.
Yeah, I think it's actually confusing, like what gender the animals are. Like, I think Tigger's supposed to be a girl, dude. Yeah, wait, no. Let's see. Gender of characters, Winnie the Pooh.
Some people have way too much time on their hands.
Okay, here we go. The character Winnie the Pooh is depicted as male. However, the real-life bear that inspired the character was female. Okay. All other main characters except for Kanga the kangaroo are male. Okay, never mind. Okay. All right. So that was the debate.
The magic roundabout.
The magic roundabout. What?
Have you heard about the magic roundabout?
No.
It was another children's TV series in the 70s. I think they were all models, possibly. But anyway, the joke is that you wouldn't have noticed because you wouldn't have noticed as a child because it's a children's TV series. But basically, every character is on some kind of drug.
Oh, it's just tripping on balls. It's tripping balls. Yeah.
So it's like one's on speed, one's on mushrooms, one's on weed, and you can sort of tell who's supposed to be who because of the way they act.
Let's see if they have like if it's in the wiki thing. Do they have it under like in popular culture? Well, they don't bring it up. I believe it though. It is always fun to watch like children's programming and then see the adult themes that are hidden in it. But like if you're a child, you're totally oblivious to it.
No, yeah. And Captain Pugwash, that's less subtle.
Captain Pugwash.
One of the characters is literally called Roger the Cabin Boy.
Roger the
Master Bates.
Roger the Cabin Boy. Oh, children's. All right. Let me do this one real quick. Okay. F of x is equal to x squared minus 3x. Then the points at which f of x are equal to f prime of x are equal to. Well, this is easy. So f prime of x is just the derivative of that. That's equal to 2x minus 3. So then we're saying that 2x minus 3 is equal to x squared minus 3x. Cool. This is a quadratic. 0 equals x squared minus 5x plus 3. So, or did I do that right? Does x equal 1 satisfy this? Doesn't. Wait, did I do something wrong here? F of x is x squared minus 3x. Cool. The derivative would be 2x minus 3. Move things over. Yeah, I get x squared minus 5x plus 3 equals 0. I don't think it works out. I don't think this works. I don't think 1, 3 is the answer. Let me double check myself with ChatGPT. Just have a go at it. I don't think they're nice numbers. I think you have to do x equals negative b plus or minus the square root, b squared 25 minus 12 all over 2. So you get 5 plus or minus the square root of 13 over 2. That's really ugly. Not a really nice equation. Yeah, that's what ChatGPT thinks too. Yes, the correct solution involves irrational roots, not integers like 1, 3, or minus 3. So the correct answer is not listed. Oh no.
Oh no.
Great job, person who wrote this. I hate that, dude. Like, when homework questions are just wrong. It happens, I guess, though. Let's see. Is 1K here? Or I think Shantrix is. Shantrix, you're here, right? Yeah. Something with magic squares. We do magic squares today, Shantrix. Here, let me download this one real quick. Okay, in the magic square, this looks like Sudoku. The numbers in each of the 3 rows, each of the 3 columns, and each of the 2 diagonals have the same sum. Does Sudoku work like this? Is it also the diagonals? What's up, Shantrix? The sum is called a magic constant. Each of the 4 figures is a magic square. In figure 1, the magic constant is 18. What is the value of n? Ooh. Okay. This is kind of a cool one. So I assume what we do is we say this. Diagonals don't count in Sudoku. Okay, that's interesting. Sudokus are... Yeah, they're cool, man. Okay, let's assume this is C then. Okay, I'm just going to call this thing C. Alright. Well, I know the diagonal, right? So 3 plus n plus C is equal to 18. And then also 7 plus 2 plus C is equal to 18. So now I can subtract these two. Right? This is just a systems of equations. So that's 0, that's 0. And then we get 3 minus 9. So you get negative 6 plus n equals 0. N equals 6. Yeah, that's not too bad. So yeah, we just found this, create another variable. It was great. This one. A little trickier. Oh. Okay. Well, we know what the magic constant is, right? Because it's adding these up. So n equals 21. I think this is a trickier one we got to do. Shadrix, let me know if there's a faster way to do it. I think we do this. I think we do 8 plus p plus c equals 21. And then we do 9 plus d plus 5 equals 21. And then 4 plus d plus c equals 21. Right? Because sum. Now I have 3 equations and 3 unknowns, and now we're okay. Benvox says p equals 3. Let's check that. So, if p equals 3, then c equals 10. Let's just make sure that checks out. So, p equals 3, c equals 10. And then d would equal to 7. So, let's see. 17, yeah, good. D here is 7. 7 plus 5 is 12. 12 plus 9 is 21, yep. And then 3 and 7. No, 3 and 10, 13. Yeah, cool. Yes. Okay, cool. P equals 3. Yeah, we had... So, in this case, we had to introduce one more variable. Anuraj says you can use matrices to solve it using elementary matrix operations. Yeah. I could write this, you're right, as a 3 by whatever. Okay. Okay, this one, I think this one's actually even easier, right? If I call this C, right? So then I have 20 plus C must be, so this total must equal this total. So that must equal 2R plus C plus 4. And then also must be equal to 2R plus 20. Right? Femvox is speedrunning. Yeah, he's doing it well. I think I want to get like what C is. Okay, so if 20 plus C equals 2R plus 20, that means C is equal to... This goes away. Oh, C just equals 2R. Okay, cool. So then 4R plus 4 must equal 2R plus 20. So that tells me 2R is equal to 16, so R is equal to 8. Cool. Yeah, that's from this. Cool, I agree with that. R equals 8. Now, Femvox, did you get U already for us? I think it might be a little harder. Well, let's see. Okay, so that tells me 3U minus 3 is equal to 2U plus C minus 2, right? 3U... Oh, okay. I think we have to introduce a new variable a here as well. So 12 plus a plus u is equal to a plus c plus u plus 2, right? And then I think we need another one. Oh, man. Because I technically have 3 unknowns at this point. Right? So we have 3u minus 3 is equal to n. 2u plus c he says, I think we can get the values for squares 2, 2 and 1, 3 in terms of u. And then it turns into a simple equation. Yeah, Andy, maybe. So, yeah, let me put it in terms of, I'm going to say that equals n. Then 2u plus c minus 2. That's also equal to n. And then 12 plus a plus u is equal to n. And then... Oh, here, I should put them in the same order. Sorry, my bad. Let me put them in the same order. Because I want it in, like, UCA, basically. Okay. So, u plus a plus 12 is equal to n. And then u plus c plus a plus 2 is equal to n. So now we have 1, 2, 3, 4. We have 4 equations, and we got 4 unknowns. So you could do this. And yeah, we did do that, right? Kyung, right? Or Andy? This is like the 1, 3 point. And then this is the 2, 2, 2. Okay. 3 minus 3 equals 2u minus 2 plus c equals u plus 2 plus c plus a. Correct. I agree with this. Yeah, that's all this is, Andy. I agree with that. But then... I need c in terms of u. So I think I have to use these two, Andy. That one was trickier. Let's call these equations. 1, 2, 3, 4. Okay. So if I do 3 minus 4, that's going to get me 10 minus c equals 0. Yeah, exactly, right. Okay, so then just c equals 10, right? Yeah. C equals 10, cool. Then once we got that... then I can do these, right? So then 1 minus 2, that's going to get me u minus c minus 1 equals 0. C equals 10. So u minus 10 minus 1 equals 0. So u equals 11. Yes! That's what Femvox got. U equals 11. Nice. Good. Very cool question, Shantrix. I like that one. Here, and that was... You kind of helped doing that one as well, Andy. I'm going to give that one to you as well. That was a cool one. Yeah. I like that question. That's a really fun one. It's like super Sudoku. But it's a great... That's a great exercise in, like, why systems of equations are so useful. And how you can use, like, matrix operations to do things. Yeah. Good strats to know. Okay, let's see. Do we have any other help screenshots? Whenever 1K shows up, I'll do his. Otherwise, yeah, it looks like we got a web screenshot from Log. Oh, this is... Let me see if I can see if this is a little, maybe a little too blurry. Let me see if I can see it. Oh my god, what? Spin tensors? Jalman ray, dude. What class is this? Oh dear. Oh no. Show that two vector kinematic jump conditions at a singular surface are equal to one equivalent tensor. Oh no. Wow. This is higher level math than I'm used to, or that I can actually do. I actually don't know how to do this. I'm sure I could figure it out because I have all the base knowledge for this. But wow, tensors is like the one thing that I never really got into at my level of math. That's when I switched off and started doing experimental. Femfox says, this is why I could never stream. People would throw stuff like this at me, but it's okay. I say throw anything at me that you want. And if it's within my wheelhouse, I'll do it right away. If it's not, and I feel like I want to learn it with you, I'll do it anyways. But then also if I'm like, I'm just tired, it's okay. I can just pass things off. I'm reaching the I'm tired, and I don't know if I can do tensor. I don't know if I can learn tensors right now. It's a little much. But it's a cool question. I love seeing things that, you know, this stuff used to like just like scare the shit out of me, and I would just freeze up and say no. But I will say, after streaming for almost 4 years at this point of doing random questions that people ask me on the internet, you start building up enough self-confidence that you know you have the toolbox to eventually learn it. Like, it's not impossible. Nothing here is impossible. It's just how much time do you want to take? This right now looks like a lot of time, and I forgot. I do have to tutor a kid in 5 minutes, so unfortunately, yeah, this stream can't be as long as it usually is. But yes, this is a cool question. Whoever asked this to me, I might do it during tomorrow's office hours. Maybe we can start it off if we don't have any other questions. I'll go through and I can learn about tensors. Let me wrap up. Oh, you post on a Discord as well? Where'd you post it? Let me do this real quick one before I gotta go. Because this is one case question. It says, a train is starting from a railway station, moving with uniform acceleration, attains a speed of 40 kilometers per hour in 10 minutes. Find its acceleration. Cool. Acceleration equals change in velocity over change in time. I don't like these units. So the change in it, so this is like 40 kilometers per hour over 10 minutes. Ew, we don't like any of these units. Okay. I have to figure out how many meters per second is equal to 40 kilometers per hour. The way to do that is that 1 hour is 3,600 seconds. And then 1,000 meters are in 1 kilometer. Okay. So doing that, a little bit of math, a little bit of calculator action, real quick. We're going to get 40 times 1,000 divided by 3,600. So that's going to equal 11. And then the time, we're going to say like how many seconds is equal to 10 minutes. Well, 60 seconds in a minute. So that's just going to be 600 seconds. So then your acceleration is equal to 11.11 divided by 600. And that's going to get you 0.0185 repeating. That's pretty cool. Meters per second squared. Nice.
Well done! Well done!
Okay, cool. All right, let me get that in for 1K real quick. That's a physics question. Nice. Tensors, www. Yeah, tensors are upsetting. Okay, I do gotta run in a minute. All right, so you might try tomorrow. Yeah, come by tomorrow if you want during the stream, and like we'll go over these questions. If you want to submit stuff, I'm happy to learn it with you guys. Okay, but that being said, I do need to run. But before we sign off, let me tell you guys like how you can figure out when we're streaming. So if you ever go to our calendar, which I'll post here in the chat for you guys. There's that. There you go. And then in Discord, it's just !Cal. But this is a website that has when we are streaming and when all our friends are streaming. So it looks like Zach has a math stream Wednesday morning. If you want to go to that, we'll be streaming tomorrow an hour later at 4 o'clock Pacific time. And then Penn Center, another really good friend of ours, is doing a machine learning course that he's kind of running himself on Twitch, and that's Friday at 11 a.m. So make sure, go by, check out the calendar, subscribe, follow, whatever notifications, and you'll see it. Okay? All right, I gotta run. Send the stream. All right, thank you everyone for coming to office hours today. I appreciate everyone's participation and questions. Sorry I had to have a little bit of a shorter stream today. I got a lot of teaching. But we will be back tomorrow at 4 p.m. Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. Come on by. Thank you, Femvox. Yeah, and if you want to come by and check out the physics course I'm teaching, that's also on YouTube at 12:30 p.m. And I sometimes also stream it to Twitch if my bandwidth is okay. So if you see it on Twitch, you see the notification, come on by, join. All right, doing that, let's go raid somebody. Looks like Obi is cracking the GRE math test. Ooh. Yeah, let's go check out Obi. Yeah, let's go learn some math with Obi. So go say hi to our good friend Obi-Wan Pez over at on his channel. Looks like he's doing looks like composite functions. Wow, that looks super fun. Okay, cool. All right. Enjoy the rest of your Monday. We'll see you guys tomorrow. Peace.